just wanna be successful. I just wanna be successful. I just wanna be successful. Drizzy.
Hello, welcome to our classroom. Today we're doing lesson 9.4, exploring quotients and functions. Our goal in this lesson is to represent the quotient of two functions graphically and algebraically to determine the new characteristics of our new function. Our main ideas. When two functions, f of x and g of x, are combined to form the function f divided by gx, the new function is called the quotient of f and g. Algebraically, this can be explained by f divided by g is equal to f at x divided by g at x. To graph the new function, use a table of values. State the domain and restrictions for the new functions. Also remember that the denominator cannot equal 0.
Example 1. For each pair of functions, state the equation of y equals f divided by g at x, and the restrictions. F at x equals 5 and g at x equals x. So we're going to write down the equation. F divided by g at x equals f at x divided by g at x. This equals 5 divided by x, which is 5 over x. And the restriction is x cannot equal 0.
So example B is f of x equals 4x and g of x equals 2x minus 1. So the equation is f of x divided by g of x, which equals 4x over 2x minus 1. So the restrictions equals 2x minus 1 equals 0. So 2x equals 1. So x cannot equal half. For example C, we have f at x, which is equal to 4x, and g at x, which is equal to x squared plus 4. So I'm going to start out by writing the formula, which is f divided by g is equal to f at x divided by g at x. So for f at x, we have 4x all over g at x, which is x squared plus 4. For our restriction, we'll take our denominator and equate it to 0. And we're going to remove our 4. And since we cannot square root a negative number, we cannot have a restriction.
Example D is f at x is equal to x plus 2 and g at x is equal to the square root of x minus 2. So firstly, let's start off by writing the formula, which is equal to f divided by g at x is equal to f at x divided by g at x. So we know that f at x is equal to x plus 2 all divided by the square root of x minus 2. We can't leave this answer like this because we must rationalize the denominator. So by doing that, we must multiply both the numerator and denominator by the square root of x minus 2 over x minus 2. So now let's try to simplify this furthermore. We know that the numerator cannot be simplified, so we're going to rewrite that. And the denominator, the square root of x minus 2, can be written as the square root of x minus 2 squared. So from before, we know that the square root sign is the same thing as saying x to the exponent half. So now let's change the square root sign over here to a power of a half. So we're going to rewrite the numerator. which is 1, x minus 2. So now let's state the restrictions. The restrictions is x has to be greater than 2. And this is because x cannot equal 2 or a negative number, because that will create a negative sign into the square root, which will make the answer undefined.
So in the example, we have f of x equal to x squared, g of x equal to log x. So we have the formula f divided by g at x equal to f of x divided by g of x. F of x equal to x squared divided by g of x equal to log x. For the restriction, we have x has to be larger than 0 because log cannot be equal to negative number or 0.
Example 2. Graph the following function of y equals f divided by g of x. State the domain of f divided by g. So A. F of x equals x minus 4 and g of x equals 2x squared plus x minus 36. Since we can't factor out the equation of g of x, we'll have to use the quadratic formula. So our A equals to 2, our B equals to 1, and our C equals to negative 36. Our quadratic formula equals x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. So we'll just put in these values into our equation. Equals negative 1 plus or minus square root of 1 squared minus 4 times 2 times negative 36 all over 2 times 2. This will equal to negative 1 plus or minus square root of 289 all over 4. This will give us two values of x equals to 4 and x equals to negative 4.5. If we were to put this into equation, this would equal to x minus 4 and at 2x plus 9. Now that we have this, we'll plug it back into our f of x divided over g of x. So our f of x is x minus 4, and our g of x equals x minus 4 times 2x plus 9. Since these two are the same, they cross out, and we're left with 1 over 2x plus 9. So the first thing we're going to do is state the restriction in the domain of our function. So we have the function of f divided by g, which is equal to 1 over 2x plus 9. So to state the restriction, we're going to use the denominator of the function. So our restriction is 2x plus 9 cannot equal 0. And our final answer is x cannot equal negative 9 over 2. Now to state the domain of our function, we will use the denominator of the original function before we cancel it out. So, using the denominator, x cannot equal 4 or negative 9 over 2. So now we're ready to graph our function. So the key thing to remember here is we have a restriction on the x-axis, an undefined point of x cannot equal negative 4.5. So I'm going to draw an asymptote, a vertical asymptote along negative 4.5. Now if you don't have a graphing calculator, the easiest way to graph this is using a table of values, which I've already done here. And using these values, my new graph is going to look like and that is our new function.
The function h at t models the growth of a sunflower, where h at t is height in centimeters and t is time in days. the maximum height of the sunflower is 260 centimeters. Calculate the average rate of change, the growth of the sunflower over the first 20 days. So the interval we're going to be using is t is larger than or equal to 0, and t is less than or equal to 20. The first thing we should do is start with the formula for average rate of change, which is equal to f at x2 minus f at x1 all over x2 minus x1. We know that f at 2 is going to be f at 20 minus f at x1, which is f at 0, all over 20 minus 0. Now let's come to the side and if we work out f at 20, we're going to get 66.36, and if we work out f at 0, we're going to get 10.4. Now let's put these values into the equation, which equals to f at 20, which is equal to 66.36, minus f at 0, 10.4, all over 20. So the answer is going to be 2.798. Now let's write a therefore statement. Therefore, the average rate of change is 2.798 centimeters per day. Determine when the sunflower has grown to half of its maximum height. The maximum height is equal to 260 centimeters. So the maximum height is 260 centimeters, but since we're figuring out half of its maximum height, we must divide by 2. We're going to get 130 centimeters. Now, let's put 130 centimeters back into the original equation to solve for t. So it's going to be 130 is equal to 260 divided by 1 plus 24.9 to the power of t. And the first thing we're going to do is cross multiply. So we're going to get 130 plus 3,120, and we're going to leave 0.9 to the power of t is equal to 260. So since we're solving for t, we're going to remove the 130 by subtracting it from both sides. So we're going to get 3,120.9. T is equal to 130. Now, let's divide both sides by 3,120 to remove it from the side. So it's going to be 0.9 to the power of t is equal to 130 divided by 3,120. Let's continue on this side. So since we have this, now we're going to multiply both sides by the log to get t by itself. So it's going to be log of 0.9 is equal to the log of 130 divided by 3,120. So it's going to be t log of 0.9 is equal to, when you figure that out, it's going to be negative 138, about that. And now, to get t by itself, we're going to divide both sides by the log of 0.9. So it's going to be t is equal to negative 1.38 divided by the log of 0.9. So when we get that answer, it's going to be approximately 30 days. Therefore, that's how many days it takes for the sunflower to reach half of its maximum height.
C. Estimate the instantaneous rate of change in height at a time of 30 days. We have the formula to calculate the instantaneous rate change. F of A plus H minus F of A divided by H. We have A equal to 30 because we're doing 30 days, and H equal to 0.01. Therefore, this one equal to F of 30.01 minus F of 30 divided by 0.01. When you work it out, F of 30.0 equal to 128.948, and F of 30 equal to 128.87953. Solve those answers into this formula. We have 128.948 minus 128.87953 divided by 0.01, and we got 6.848 centimeter per day.
Thank you for watching our math tutorial. We hope we were successful.
I suppose I just wanna be successful. I just wanna be successful. I just wanna be successful. Drizzy.